right? So that is how you would rewrite the absolute value notation given interval notation, okay? So we're gonna move on to example 4. We wanna rewrite each statement without absolute value bars and graph it on a number line, okay? So all it wants us to do is just graph it on a number line, okay? So if we have the absolute value of x is greater than 3, how would I graph that on a number line? First of all, am I gonna have open circles or closed circles? Open, and where am I gonna have those open circles? Yep. So that's how you would draw that absolute value inequality for absolute value of x is greater than 3. Okay? So the next one we have is the absolute value of x is less than or equal to 2. Okay? So what type of circles am I going to have? Open or closed? Closed, okay? And where am I going to have those closed circles at?
Negative.
Okay? Am I going to have the portion in the middle highlighted or the portion on the outside of each one highlighted? In the middle, okay? Because it has to be less than or equal to 2, and all the values in here are less than or equal to 2, okay? So as you can see, with absolute value, it's just about reading the inequality and just thinking logically about it, okay? There's not, for some, it might be hard to understand, but if you really just look at the question and you think, hey, for example, A, all the values have to be greater than 3, the absolute value, so all my arrows are going to be bigger than positive 3 and less than negative 3, okay? So we have a couple more examples. We have a graphing example that we're going to do together right now. So for example 5, we want to graph the function f of x is equal to the absolute value of 2x plus 1, okay? So first, what we have to do is we just want to graph the parent function, or the function without the absolute value, which is 2x plus 1, okay? So if we're graphing 2x plus 1, what would my y-intercept be? 1, so 0 and 1. And what would my x-intercept be? If we set y equal to 0. Negative 1/2. Okay? So it's going to be right here. All right? And obviously, if we were to draw this regular line, it would be extended on quadrant number 3, okay? But because we have the absolute value function, all of these negative values on quadrant 3 turn into what? Positive, okay? So you're essentially reflecting this back onto the x-axis to get that absolute value function. Okay, so step 2 is you're going to reflect the negative portion of 2x plus 1 onto the positive axis. Okay, so as you can see from here, Regularly, this line would just be extended here, but because of absolute value, it's just reflected back onto the y-axis to get the graph. So is everyone okay with that explanation? Right. So we have example 6. So we want to state the solution to each inequality and graph it on a number line. Okay? So so A is the absolute value of x is less than -2. So is there a solution to that, or is that not possible? Can the absolute value ever be a negative? No. Okay, so it's not possible. And it's not possible because the absolute value is always positive. Okay, so which means we have a empty set on the number line. Right, and therefore we have no solution for this answer. Okay, so take note, we also have a negative number in B, but take a look at the inequality. So B is the absolute value of x is greater than or equal to -3. Is that true? Can that happen? Yep. So this is always true. And where would I draw it in the number line?
Those dots on 3 and -3.
Okay. Great. And where would I be going? Connected? All right. But with that inequality, okay, think of the absolute value, okay? Is it true for all numbers that the absolute value of x is always greater than or equal to -3?
Equal to.
Right. So give me a number that's outside of, to the left of -3.
5.
Okay, so we have absolute value of -5 is greater than or equal to -3. What's the absolute value of -5? Is that true? 5 is greater than or equal to -3?
Yes.
Yep. So if we keep going to the left towards -infinity, it is always going to hold true. If we go to the right to +infinity, it's going to always hold true, right? Because if we take the absolute value of 0, 0 is still greater than or equal to -3, correct? So what would our number line look like? It would extend. There would be arrows on both sides because it's true for all numbers in x, okay? So true for all x values. So you would have x ER for this solution. Okay? So does everybody understand the reasoning why it's XCR for B? Okay. So here we have what to look for when you're doing the absolute function. Okay, so if symbol is greater than or equal to, the operator is or. Okay, so if a is greater than 0, then the solution to absolute value of x is greater than a. Is the absolute value of x is greater than a, or the absolute value, or x is less than a. Okay, because when you throw back the absolute value, it's always going to be bigger than a. Okay, so let's just say a is 3. Okay, so you have positive 3 and negative 3. Okay, so you have right. So let's just take an x value. Let's take positive 4. Okay, so you have absolute value of 4 is greater than a, which we said is 3. 4 is greater than 3, which is correct. Okay, and then let's take a value that's negative, that's less than negative a. So negative a would be negative 3. Okay, what's a value that's less than negative 3? Less than
Negative 5.
negative 5. Okay, so we have negative 5. Okay, is greater than a. Absolute value of 5, we said a is 3, is greater than 3. So that is also true. So if a is less than 0, then the solution to the absolute value of x greater than a is the element of all real numbers. Okay? Which is what we had in the previous example that I showed you guys. Okay? And if the symbol is less than or less than and equal to, the operator is and. Okay, so if a is greater than 0, then the solution for the absolute value of x is less than a, is x is less than a, and x is greater than or equal to negative a. Okay, so you have this notation over here. And if you refer to, I believe it was example number 3, this would have been very helpful to solve for those inequalities. Okay, so if a is less than 0, then the solution to absolute value of x is less than a is going to be no solution, which we had in the previous example with the number line. The absolute value of x is less than negative 2. Okay, because the absolute value will never be less than a negative number. It will always be greater than a negative number. So there's some good news. The other course last quadrimester didn't get to trig identities because of the schedule. So I'm not saying it's 100% certain, but there's hope that you guys might not be doing it, depending on how much we get done from right now to Unit 5. Okay, so there's a chance there's no trig identities this quadrimester, but there also is a chance. So if we happen to get to it, then we'll do it. But if I have to rush it, I'm not going to rush trig identities because it's just going to confuse you guys. All right? So just saying there's a chance, no trig identities. And the last unit, I believe they didn't do either, which is rates of change. But you guys will do that in calc if you guys are taking it in quadrimester 3, right? So yeah, just for you guys to know, we might not be doing trig identities, right? So we have the last example. So we want to solve for x and graph on a number line. So we have the absolute value of x minus 1 is less than or equal to 5. Okay? So how many cases are we going to do for this question? And we did a problem similar to this in one of the first few examples of this lesson. Two cases. Okay? We have case 1 and we have case 2. So for case 1, we're going to have 2x minus 1 is less than or equal to 5. And for case 2, we're going to have 2x minus 1 is greater than or equal to negative 5. Okay? So for the first case, we're just going to move the negative 1 over. So we got 2x less than or equal to 5 plus 1. Divide both sides by 2. So we got 2x less than or equal to 6. Divide both sides by 2. X is less than or equal to 3. And then we're going to do the other case, which is case 2. So we have 2x minus 1 is greater than or equal to negative 5. So we're going to move the 1 over. So we got 2x is greater than or equal to negative 4. Divide both sides by 2. And we get x is greater than or equal to negative 2. So if I were to have a number line, how would I draw my solution on a number line? Based off the fact that x has to be greater than or equal to negative 2, and x has to be less than or equal to positive 3.
Close bracket at negative 2 and 3 and connecting.
Okay. Negative 2, 0. Okay, so how can we verify that this is true? Pick a number. Okay. Pick a number that's between negative 2 and 3. Negative 1. So we're going to sub negative 1 into the original, okay, equation. So if we sub in negative 1, we get 2 times negative 1 minus 1 is less than or equal to 5. So we get negative 2 minus 1, which is negative 3. And what's the absolute value of negative 3? It's just 3. So is 3 less than or equal to 5? Yes. So that means our solution that we did on the number line works. Okay, so this is correct. Okay, the next example we have is absolute value of x plus 8 greater than 2. So what's the first thing I'm going to do? Split it up into 2 cases again. So what is my first case going to look like?
X plus 8 is greater than 2.
Okay. And what would my second case look like?
X plus 8 is less than negative 2.
Yep. X plus 8 is less than negative 2. So now all I'm going to do is basic algebra, which you guys did in grade 9, 10, and 11. So we're going to isolate for x, which means we have to move the constant over to the other side. So we get x is greater than 2 minus 8. So we get x is greater than 6, negative 6. And for case 2, we have x is less than negative 2 minus 8. And we get x is less than negative 10. So now we have to represent this solution on a number line, okay? How would we do it?
Open circle at -10 and -6, connecting each other.
Connecting or not connecting? Okay, so if we connect, that means we're bound to just between -10 and -6, right? So
Oh, no,
No, no.
would it be splitting up?
so it's the other way, yeah.
Okay. So the reason why they would have to go to the right and to the left, because any number that's between -10 and -6 is going to give you a number that is not bigger than 2, okay? So let's take, for example, -9, okay? If we were to sub -9 into x, so you get -1 is greater than 2. Is 1 greater than 2? No. Okay, so this does not work, okay? And when you're looking at these solutions and you're making a number line, just make note of these inequalities, okay? And that will help you determine which direction to go, okay? So as you can see here, x is greater than -6, it has to go all the way to the right. If x is less than -10, it has to go all the way to the left, okay? For your Unit 1 quiz, it'll probably be on, let's see. So cohort B is here on, I'll probably make it Thursday, that way you guys all can do it online, okay? It'll just be a Google Forms quiz, so it'll be basic knowledge questions. In terms of the thinking and the application, I'll probably have to split it, so cohort A writes it on one day, you guys write it on the other day, and then cohort C gets everything online, right? But that's it for 1.2. You guys have Baxter, the bulldog, ends up barking at 10:40 anyways. So you guys have literally 10 minutes to, or 10 to 12 minutes to start on the homework. And then tomorrow we'll go on to 1.3 and 1.4, right? So that's basically it for the day. Cohort B and C, you guys just work on the 1.2 work. Your quiz is going to be Thursday.